This is a demonstration of running a job through the current version of RapidShell, version 1.76Z. So first we'll load a sample job. We're using Short Step Podiatry's Casey Glover case here, as the scan meshes are quite simple. We open the script file. We then display the left foot. We now need to align the left foot, place 3 points, heel, ball of the foot adjacent. We align that. The difficulty I had in placing the points was because my mouse buttons are wearing down and the middle mouse button pick is a little less than ideal. So we'll just quickly give this a rough alignment. We'll also raise the toe area. This is not as precise an alignment as a normal podiatrist might do. We're just testing the operation of the program. So we set some reference points, arch, heel, heel, forefoot, forefoot. We only have one option for creating the orthosis model, accept that. We have a red insole, we can turn off the toolbar. We check that is for a left foot, which is correct. We then export to STL. The new option is create check file, so we'll select that. This is a relatively slow computer, so we'll ignore the serial number and we'll create insole. For some reason it always goes to the incorrect data directory, which I'll need to check. So we go to Short Step Podiatry, one level down, and we save. We replace that. It will now create a 3D STL file for 3D printing. As part of creating the check file, it will also end the processing with not only the red insole visible, well, but in a grey colour, but also the original scan mesh, so you can quickly compare the two. Takes a few seconds to process. Now we have our 3D geometry for the insole. And we now have also the 3D scan mesh. This same geometry is saved to disk as a file with the same job name, but underscore check at the end of the file name, so you can identify it and pass it back to the podiatrist if you need to. That's the left foot. We now display right foot. Again, we align it, placing 3 reference points. Align that. Quickly put it into position. Note also the 3 scaling factors we now have. So if I go to 10, I get quite a rapid step size. If I go back to 1, get the default size. Raise the toes again slightly, add reference points, arch, heel, heel, forefoot, forefoot. This time we'll create the orthosis from the previous insole, accept that. It's built the red insole. This time we check that is for a right foot. We then export STL. Again, we create the check file, create the insole, determine the right output directory, overwrite the existing file, and processing here is not to precisely set up the job, as we're quickly just processing through a job to make sure everything is operating correctly. Just wait a few more seconds for the job to complete. Process the insole, so we now have our 3D insole geometry. Just completing, and we now have our 3D insole with the raw scan mesh. Again, this will have also been saved as an LCF file on disk, so it can be checked later. Okay, at this stage we can quickly check what we've got, so we can decrypt the two STL files we've just created. So decrypt the left insole. That's done. Decrypt the right insole. That's done. Close that file. We can then go into Mesh Lab, import the mesh, data, sure step. Here's the left insole. Import the mesh for the right insole. So we produce the two meshes, and if we go into the directory we're in, you can now see we have check LCF file for the left foot, check LCF file for the right foot. We have our encrypted right foot STL and our decrypted right foot STL, and the same encrypted STL for the left foot, decrypted STL for the left foot. All the files have been produced. That is a quick demonstration showing that I don't seem to see some of the problems you've reported in when you're running the program. So that can be a starting point for further discussion. Thank you.